Hi, I am Vaishnavi Mure, a data science and business analytics intern at the Sparks Foundation. And today, I would like to share the second task of my internship named Prediction Using Unsupervised Machine Learning. But before that, I would like to talk about unsupervised machine learning. So basically, in unsupervised machine learning, our model is getting trained without being under supervision. Now, what does that exactly means? So basically in previous video, I talked about supervised machine learning. That supervised machine learning is a type of machine learning in which our model gets trained based on the past experiences. That is based on the input and output of the previous data. That is in short, our model is getting trained by being under supervision. But that does not happen in the case of unsupervised machine learning. In unsupervised machine learning, our model gets trained by only past experience input part, that is the previous data's input part. We just need to pass the input to our model and our model will get trained on itself without being under supervision. So that's what unsupervised machine learning is. So now let's understand the problem of our task. So the problem is, from the given iris dataset, predict the optimum number of clusters and represent it visually. Now what we have to do in this task, we will be provided with iris dataset, and from that dataset we have to predict the optimum number of clusters, and after predicting we have to represent it visually. That is, we have to visualize the result. So before that, we should know what does clusters means. So basically clusters are the small groups of data in which the data points are having similar characteristics. Now, let me explain in this way the clustering process. So clustering is the process in which the large data set is divided into small groups where each and every data point is having similar characteristics. Okay. The real world example of clustering which I can give is, if you ever have visited your college library or any library, you must have seen that the books are divided based on the year of studies. That is, first year section is different, second year is different, third year section is different, and final year section is different. So you can consider the complete data set as the complete library and the clusters as the sections for the first year, second year, third year, and final year. Another best example which I can give you of clusters are, if you ever have visited the shopping malls, you must have seen that there are different sections. That is, the grocery section is different, the clothing section is different, the electronics section is different, the sports section is different, and so on. So you can consider the complete shopping mall as your data set and the clusters as this different section. So basically, what are the applications of clusterings in machine learning or in our field? So you must have seen the recommendation systems. Netflix use the recommendation systems to recommend you movies. Amazon Prime also use that to recommend you movies. Then Amazon and Flipkart and many other sites use recommendation systems to recommend you product and so on. And another thing, way where the clusters are being used, or this clustering process is being used, is search engine. This is the most famous example, and so on. So these are the applications of clustering. I hope you have understood what unsupervised machine learning is, what these clusters are, and what their applications are. Now let me talk about types of clustering. So there are basically three types of clustering. The first one is exclusive clusterings. So here what happens, each and every data point belongs to only one cluster. That is, for example, the any electronic item will belong to only electronic section in the shopping mall. Any grocery item will only belong to the grocery section of the shopping mall. So you can take this example as exclusive clustering. And in machine learning, for doing this exclusive clustering, we use K-means algorithm. Then there is second one, that is overlapping clustering. Here, a data point may have multiple clusters, or they may belong to multiple clusters. For example, in clothing section, there are women section different, men's or gents section different, and kids section different. Consider a unisex t-shirt. Unisex means female and male both can wear it. So consider that kind of t-shirt. So that t-shirt will belong to gents section also, ladies section also, and if we decrease its size, it kids can also wear it. So that belongs to kids section also. So a single data point is belonging to multiple clusters. So such kind of clustering is called as overlapping clustering. And third one is hierarchical clustering. So as in this problem, I will be using exclusive clustering. I have explained it in detail. I hope you understood it. Now that we have understood our problem, the second step is finding the source of data and loading it. So basically you can load the iris data from sklearn model also. Sklearn is a machine learning module, which has some inbuilt data set. So iris data set is one of them. So you can import it from there also. But Sparks Foundation provided me this link. It is a Google Drive link where I can download this data set. So I downloaded it from this link only. Then for loading it, I have used pandas module. So pandas module is basically used to load the data set in this problem. I'm using it for that only. So in that pandas module also I have used this read underscore CSV function for reading the data set. So what does this pandas modules read underscore CSV function is doing? It is reading the CSV file and converting that data into data frame and then returning the data frame. So I have stored this data frame into df variable, and just to take the overview of my data set, I am printing the first 5 rows of my data set. So you can see that there is ID column. ID column is having basically unique values for each and every row starting from 1 and so on. Then there is sepal length column, sepal width column, petal length column, petal width column, and species column. So this is what the data set looks like. And if you want, you can also print the last 5 rows of your data set. So tail function is printing the last 5 rows. So from here, you can know that there are in total 150 entries in our data set. So this is not enough. We need to explore our data set more, and that's why I'm using this info method over my data frame, which is returning me these many information. Like there are 150 entries starting from 0 to 149 is the range of them. There are 6 columns and there is not a single null values in any of the column in any of the row. That is, we don't need to do a lot of pre-processing part or cleaning part. So that's a good sign. As this is a beginner level problem, so we got this data set which is pre-cleaned. Okay, now to know more details, like some mathematical details related to the data set, I'm using this describe method. So this is giving me some more insights of this data set. So as you can see, when I printed the first 5 rows, I saw the species as Iris setosa, and when I printed the last 5 rows, I got the species as Iris virginica. So I thought that I should check how many total unique species are present in our data set. And for that purpose, I choose the species column and I use this unique method over it. So when I'm doing this, I'm getting an array in return, which is saying that there are only 3 entries: Iris setosa, Iris versicolor, and Iris virginica. So when I saw this, I thought that whatever data point I will be passing to my model, it will be either from Iris setosa cluster or Iris versicolor cluster or Iris virginica cluster. So from this, I came to a conclusion that the optimum number of my clusters should be 3. Okay, yeah. But this is not the best way to know the optimum number of clusters. So we will be looking towards the best way, but before that we should know what K-means clustering is. So basically K-means clustering is algorithm whose main goal is to divide the huge data set into small groups of similar data points into clusters, and the K in K-means means the number of clusters. So here from the unique method, I concluded that I will be having 3 clusters. But as I said, this is not the best way to find the optimum number of clusters. The best way is the elbow method. Now, what this elbow method is, let's see. So first of all, I am going to use this K-means algorithm. So that's why from sklearn.cluster, I imported K-means algorithm. Now I just want this sepal length column, sepal width column, petal length column, and petal width column. I don't want this ID column and I don't want this species column also. So if you want, you can drop these two columns, but I'm not dropping it. I'm just using this df.ilock method where I'm saying that give me all rows of first, second, third, and fourth column. So I'm using this method to choose only first, second, third, and fourth column. So if you see the data set carefully, you can see that zeroth column is ID, first column is sepal length, second column is sepal width, and so on. Fourth column is petal width. Okay, so I'm selecting first, second, third, and fourth column. So I selected values from those column and I put it into this X variable. So now what I'm doing is I have created one list. Why I have created it, I will explain. So basically I have created this list and now I'm iterating over the range of 1 to 11. That is, I will be iterating 10 times. And every time when I'm iterating, I'm passing this number of clusters to my K-means algorithm to be the number of iteration. That is, for the first iteration, the number of cluster will be 1. For second, it will be 2. And so on. For 10th iteration, it will be 10. So basically I'm trying random values of clusters, not random, in a series I'm using the values of clusters to check what is the best optimum cluster for my K-means algorithm. So after this algorithm is used, I'm just fitting my data to it. That is, all rows of those 4 columns I'm fitting to it, and I'm appending this to my list. And WCSS means within cluster sum of squares. So I'm appending my result to this list, and after that I'm just visualizing it. So it will take a few seconds. So for visualizing again, if you can see here, I have used this matplotlib.pyplot, and from that also I'm plotting a line plot where I have passed range to be 1 to 11. That is again the range, the entries will be from 1 to 10, and I'm passing my list, and then I'm just showing the plot. So basically it is a line plot where you can see that my elbow point is somewhere between 2 and 4, that is here, and it is exactly in between, which makes us know that the optimum number of clusters are 3 only. So this is the best way to know the optimum number of clusters. This is called as the elbow method. So now that we have understood that, yeah, optimum number of clusters are 3 only, so let us build our actual model over our data set. So basically I'm again using this K-means algorithm, you can see here, and where I'm passing the number of clusters to be 3, and I'm passing the max iteration to be 300. That is, maximum 300 times my iteration will takes place. So if you want, you can pass any other number. I'm choosing 300, and then as this model is created, again I'm fitting my data to it. And if you want, you can check the labels also. So 0, 1 and 2 are the labels. And now we have to visualize this. Like we have known what are the optimum number of clusters, they are 3. And now it's time to visualize it. And for visualizing purpose, first of all, I built my model, and now I will be visualizing it. So basically what I'm doing is I'm using this kmeans.fit predict for my prediction purpose. Now what does this fit predict does? It returns for each and every data point, it returns us that in which clusters that data point belongs. Like for example, a data point is passed to it, the model, then this fit predict will return us to which particular cluster that particular data point is belonging. So I'm passing my complete data to it, and it is giving me the same thing in return. Now for visualizing purpose, I'm only selecting the first two columns, that is sepal length and sepal width. So I'm representing it with 0, you can see, and I'm seeing that when y underscore k means, now what are the possible values of y underscore k means? We can see from the labels they are 0, 1 and 2. So the possible values of y underscore k means can be, that is, the clusters will be 0, 1 and 2. So for that purpose, first of all, I am checking for my data if y underscore k means, that is the cluster is 0th for the 0th column and the first column, then the label will be iris setosa, and basically C is the color. I have set it to be red because I'm plotting the scatter plot, and the size of my marker is 80. The same I'm doing for when the cluster is first cluster, that is iris versicolor for 0th and first column. So I'm setting the color to be blue and the marker is again 80. Now the same thing as I'm doing for the third cluster, that is which is having the value to be 2, that is Iris virginica, and I'm setting it to be of green color, and my again marker is of 80. Then I'm also plotting the centroids of the clusters. So we can get the centroids of the cluster by using this cluster underscore centers underscore method. And I'm getting to know the centroids for all rows of the 0th column and the first column. And my labels will be centroids. And I'm basically just visualizing it. So here my graph is present, where you can see that red one are the Iris setosa clusters, green one are Iris virginica clusters, blue one are Iris versicolor clusters, and purple ones are my centroids. So here I have completed the second task.